So without further ado, I'd like to introduce our first speaker, Ken Mugrage, who's going to do a magical talk. There's only one thing you need to do DevOps.
There's only one thing you have to change. It's very easy. Yep. Let's just get this plugged in real quick. Well, I'm plugging this in. Thank you, Anton, because we'd love to see more speakers to all the Devopsdays events. Also, if you look at the Devopsdays Seattle Twitter feed, just last week, we paid someone to do CFP training. So they did online training on how to write a good proposal to increase your chances of success. And that's available online. If you look at the Twitter account, it's there, it's archived. You can watch that video. It's not specific to Devopsdays, it's for any conference. We don't need to see my email. Okay, this is going to go very fast. I have to be honest, this was originally meant to be a little bit longer than a 30-minute talk, and last night the dinner was too good for me to refactor the talk, so I'm just going to go really fast. People might be familiar with this quote. Werner Vogels from Amazon said this 12 years ago in 2006, talking about how at Amazon, if you build a piece of software, you are responsible for running that piece of software. The quote's been used many times to say that they do this to reduce costs, or they do this for, no ops, or, et cetera. And it actually is not true. It's not why they did it at all. If you look at the context of the quote in the actual full interview, which is on the bottom there, they did it to bring development teams into closer contact with the customers. They did it so that they knew if they changed something in their service that showed people suggestions for new shoes, that sales went up instead of down. So if they went up, they could build on that feature. If they went down, they would take the feature off. It wasn't about operations at all. It was about those teams operating their own software, but it wasn't about those teams operating the underlying operating systems and so forth. So the talk today is, you only have to change one thing to do the DevOps. There's a catch though. It's everything. Okay. Often I see people that are saying, oh, I got a new tool. Tools don't solve problems. I work for a tool vendor. They don't solve problems. Or I changed this, or I changed that, but I didn't do the other things. It's just the same thing as we saw in Agile 15 years ago and more. I stand up for our meetings now. I'm Agile. No, you actually have to make some changes. I'm going to go through some of these, and some of them are hard, and some of them aren't. So real quick, the things I'm going to go through. I believe it's important to define words at the organizational or team or micro level. There is no accepted definition of DevOps, and I think that's probably okay. But I think it's not okay necessarily inside your org, so I'm going to go through that a little bit. Speaking of org, a lot of times, if there was really only one thing, the thing you're most likely going to have to change is your organizational structure. We talk about modern architectures, how that helps, and a little bit about CD. So where this talk comes from, I've been with ThoughtWorks for coming up on 10 years now, working in our continuous delivery tools most of the time. I also been organizing Devopsdays Seattle for a number of years, and I joined the global core team last year. And so somebody told me the other day that a technology advocate or a technology evangelist, our job is to be professional anecdote givers, so that's what I'm going to do. So things I've seen at 50-some Devopsdays events, things I've seen at 10 years at our clients and so forth, patterns that have worked and patterns that have not. So first off, when it comes to words. I'm a bit of a word purist, and I apologize in advance if anybody feels insulted by the next slide, but I'm going to say some things that aren't DevOps. It's not a tool set. Okay, it's like, what do you do? Oh, we do DevOps tools. What's it for? It's for monitoring. Mine's for configuration management, and mine's for continuous delivery, and mine's for whatever. It's too big. There can't be a DevOps tool. Might be in the market, but it needs to be more specific. This is the part where I hope I'm not, I know that DevOps engineer in the United States right now is the second hottest job title. But it's really not a very good job title because it doesn't really say what the person does. Are they in infrastructure automation? Are they a developer? Are they, et cetera? It's also not a team. What I find helpful is to, instead of thinking of DevOps as developers and operators, in other words, nouns, to think of it as verbs. It's developing and operating software, which is inclusive of all the things required to do that. So this is why a lot of language purists like myself object to things like DevSecOps, because that lets DevOps off the hook. I do like that there's focus on it. Don't get me wrong, you'll see some security and there's some security talks later. But if you're doing DevOps and they're doing DevSecOps, sorry, you still have to do security. Okay, so I think of it as the verbs. One of the more accepted acronyms to define DevOps is CAMS. Came out of John Willis and Damon Edwards. John is the one who was at the first Devopsdays in 2009 in Ghent that brought it back to the US and really turned it into the firestorm that it became. And he wrote this blog in 2010 when he was worked for Chef. CAMS, basically, the first one is culture. The second one is automation, measurement, and sharing. So by culture, we don't just mean be nice to each other. Please be nice to each other. And empathy and understanding, et cetera. But it's like organizational culture, the structure and so forth. Is it a generative organization versus a pathological organization, and all these things you'll see in the State of DevOps report. Automation is certainly a big part of it. Usually when I see someone, their title is DevOps engineer, their job is automation. Measurement, a lot of the lean principles come in here. As a matter of fact, some people later said we should have lean in here and call it comms. Measurements, how do you know you're getting better? Beware though, metrics drive behaviors. So in the State of DevOps report again, in 2016, they showed statistics on how often people deploy. And in 2017, the deploys per day went up, but the mean time to repair went down. Or the mean time to repair also went up, sorry. So they were deploying more often, but it was worse software. Because what they were measuring is how many times a day are you deploying. And people, if that's what I get my bonus on, that's what I'm going to fix. So the quality actually got worse. So for the purposes of this talk and discussions that you might have with me, this is my definition of DevOps. I'm not saying adopt it, I'm not saying it's right, I'm saying when I say DevOps, that's what I mean. Okay, so regardless of title, this is security people, it's system administrators, it's user experience, it's developers, it's all of the people from, as John Willis would say, idea to cha-ching. What should it do? How are we going to do it? How are we going to do it? What's the architecture going to be? Et cetera. So again, don't adopt mine, don't adopt John's, but adopt your own if you need to. But it's very important that if you're on team A and you say to team B that we did the functional test, that they know what that means, that you have those words defined. Organizational structure. Who's been through like Agile 101 training, like Agile Fundamentals or Scrum or Lean? Okay, so you've seen this chart, the traditional model. We have our development teams, and we have our testing teams, and we have our operations teams. And testing could be security, it could be compliance, it could be whatever. Operations team could be internal, it could be Amazon. But these silos that are out there. And of course, the bars that we always put in there to say that communication isn't there. And it's really not. It's incredibly rare that the operations teams understands the business effect of the new feature that was added to the software. They might know what the tech stack is, they might know how to run Kubernetes, but they don't know why we're making these changes to the software, and so they can't help us. Now, there's a thing, Conway's Law, and I can't believe I'm the first one, I think I'm the first one to put this on a slide at Devopsdays. It's usually on 3 or 4 presentations. The funny thing about Conway's Law is it was written 50 years ago. And it basically says that a system's going to mirror your communication structure. And the same is true of software. If you have a division that does credit card payments, you're going to end up with an architecture where they do credit card payments. So if we go back to our traditional model, some things that don't work. So if you look closely at the upper right-hand side, renaming the operations team, DevOps team does not work. Sorry. See that a lot. And they did add some things. There's some automation, et cetera. Okay. Forming a 4th silo does not solve the problem of silos. So creating a DevOps team that does everybody else's automation for them, but they still don't really understand how things are being deployed and how it works, also does not work. There are some exceptions. Like you can do like CI as a platform, et cetera. But generally speaking, as a mentor team, awesome. People that know how the Kubernetes works, to go in and embed on those teams, et cetera. That's cool. But please don't just offshore your DevOps to somebody else. You can't do that. So what we really want to see is going back to that Amazon model of product teams. So you'll hear a lot products over projects or projects. Projects have a set start and end date and so forth. Building a building is a project. Most software is not. Unless it's for an event and you're going to just destroy it after the event's over. Most software continues to live on for an indeterminate amount of time. So we'd rather have product teams. But this can be hard if your systems, because remember Conway's Law, your systems are going to do it. So you might have to also change your architecture. We had a discussion, I think it was last night at dinner with some folks, and they were, or actually it was one in the open spaces, we were talking about trunk-based development and so forth. And they're saying, well, yeah, that won't work because our architecture, somebody changed something, and we didn't know until hours later that it broke something else and so forth. And so it is possible that in order to get all of the benefits of fast time to market and so forth, you might have to change architecture too. Not that you can't do continuous delivery on a monolith, you absolutely can. Okay, but how big is it, and et cetera. So monoliths themselves can be hard if they're big. So real customer. We had a customer who was a travel agency, do online booking and so forth, and they had a very large monolith, and like all monoliths, and this is not news to anybody here, all the functionality is in one process, and so if you want to scale it, you replicate the whole thing. Their problem was that there are things in that industry that change very, very quickly. So airlines have a new special fare class, what have you. In country A, a lot of people will rent or hire cars. In country B, they do not. But if they wanted to scale the ability in country A to hire cars, they had to scale in country B, because it's a monolith, and you have, They also, when we got there, we asked them, well, how often are you deploying to production right now? And they said about once a week. We're like, well, that's pretty good for this size of thing. I said, yeah, but it was the code freeze from 6 months ago. So, okay, maybe not so good. And so it was literally 6 months plus a week for them to get a new feature into production. So what they decided to do was the old decompose the monolith. Now, ThoughtWorks has been blamed, my company's been blamed for introducing the word microservice. If it's true, I apologize. That said, I think I've already said that I think words matter. And so, like if you're inside my company and you say microservice, everybody knows that means an independently deployable piece of software. If there's two things you have to deploy together, not a microservice. If there's two things sharing the same database or backend or data structure, not a microservice. A microservice is independently deployable. Any breaking changes to APIs and that kind of thing will be versioned so that they aren't breaking changes. The consumer continues to use version 1, et cetera. And so the idea behind this is they needed to take out the things that they needed to scale the most into a true microservice, not decompose the whole monolith, not take 2.5 years and tear everything apart, tear apart the thing they needed to scale now, created it as a microservice, changed all the calls in the monolith to that one, shut down 70% of the machines they had in production. Imagine that cost savings. Scaled the microservice up, and they could actually react now. This was 6 years ago, and now basically everything has been decomposed. But you don't have to do it as all at once. You can do it piece by piece using the most important stuff. And now they can distribute those across the servers. So then if we go back to our teams, these product teams become things that own part of the business. So now we have a team that does rental cars. And they know that business, and they know how to deal with the big agencies, and they know how to deal with the airports, et cetera. We have a team that specializes in tax or payments or hotels or et cetera. And so these become products, not projects. Homework, because it's only a 30-minute talk. And full disclosure, I think most of the books in this are going to be either current or former coworkers. Evolutionary architecture is about building architectures that you can change, and building microservices is probably pretty obvious. Okay, but we still have to deploy somewhere, right? I mean, there's still computers out here somewhere. I'm a big fan of platform as a service. Was talking with people at dinner last night, and they were saying, yeah, but if we're having platforms, are we really doing DevOps? Are the operations people really talking to the developers or what have you? But again, I think of DevOps as developing and operating that product. Doesn't necessarily mean those are the people that change out a hard drive or do a Linux patch or do a what have you. It could be, but I like platforms. So one of the ways I talk about the difference, because these things get all messed up. I don't know if Daniel already left. He had to catch a plane. I wanted to add functions as a service on here last night, but I didn't. But an on-premises, you bought the car. You own it. It's your problem. You pay for it. Tire goes flat. You fix it, et cetera. And then you have lowering levels of responsibility. And when you get a platform as a service, that's kind of like going and picking up a car for the airport. So you're responsible for the fuel, and you have to drive it, and you pay the whole, but they do everything else. They worry about the depreciation of that car. They worry about all the costs. They worry about maintenance for the most part, all the renewables, et cetera. You just get to use it. An example I use a lot, and I apologize because it's a US example, and I try not to do this when I'm not in the US, but it's a good example. There's an organization in the United States called cloud.gov. So if you're a US government agency and you want to run on the public cloud, there's a huge number of things you have to verify that you're doing. It is 325 required security controls. So this is everything from how we're doing DNS to operating system patches, et cetera, et cetera, et cetera. What cloud.gov does is they provide a platform that organizations under a certain level of risk can use. And on that platform, if you use their app stacks, so kind of like Heroku, we have an app pack. If you use theirs, they'll handle 269 of those. So you don't ever have to worry about operating system patches and all of that kind of stuff. That's going to be handled by cloud.gov. They've got the certifications. Everything's good. 41 are shared, and 15 are still your responsibility. So again, if we go back to developing and operating, okay, yes, security is everybody's job. And I'm really happy there's so much security focus in the CFP here this year. But you do still have specialties. Okay, I had dinner last night with a young woman who was telling us that she loves staying up all night and finding that bug and finding that thing. That's so awesome. We're never going to replace people like that. We have to have people like that. But we can take some of this off of the dev teams. I put this in because Daniel used it, because it's true. Yeah. Oh, he is still here. Okay. Because there's still a computer somewhere, and someone has to run it. And so if we go back to our product teams, a lot of times when I go through this, people are like, but I'm a system admin. I was a sysadmin at an ISP more years ago than I care to mention. I'm an ops background. I don't want to be on a product team. There's probably people in this audience that are like, no, I don't want to be on a product team. I'm saying the product's to be developed by teams. I'm not saying everybody's actually on a product team. Okay, there's still other specialties, and they are specialties. And so inside my organization, we have an organization called TechOps, which knows nothing about the software we build, but they provide some platforms. And we are their customer. So again, products, not projects. So we make feature requests to them as consumers of their platform. This could be AWS, this could be Azure, this could be IBM, this could be whoever. But there's a team that knows how to change hard drives, or is willing to change hard drives. I know how, but I don't ever want to do it again. Those people still exist. Compliance. Anybody dealt with GDPR lately? Okay, this stuff ain't easy. And so it's really unlikely you're going to have a full-time compliance person on your dev team. So these people still exist. And oh, by the way, we still need the people who sit in the dark room and hack away at our software. We still need white hat hackers because we can't automate all the security. We can automate some of it, but not all of it. So how do these roles come together if we want to deploy more often? So Jez Humble and David Farley wrote a book called Continuous Delivery. It's actually on the next slide. That's what it looks like, going back. And this is Jez's definition of continuous delivery. Couple important parts here. Notice that it says changes of all types. New features, configuration change, bug fixes, and experiments. So like A/B testing. We monitor all the things about our software. We know how much memory it's using. Do we know if that feature we put in, the discrete feature, increased or decreased our business? We should. Those things can be tested. And safely. People tell me often, I have a pipeline I can deploy to production in 12 minutes. Like, bull. I mean, you might be able to do it, but you didn't do compliance tests. You didn't do security tests. You certainly didn't do performance tests in 12 minutes. Okay, I'm not saying that there shouldn't be a path to get that way if you have an emergency, if you have a security problem or whatever, but please don't optimize for speed for the sake of speed. Optimize for speed if that's important to your business, but don't do it just to do it. And that's the actual book. Yeah. So I often say this. People keep, the title of the talk is, one thing you have to change to do the DevOps. You can't do DevOps. Okay, you can do continuous delivery, you can do configuration management, you can do automated testing, et cetera. Can't do the DevOps. Very quickly on continuous integration. Continuous integration is a prerequisite to continuous delivery. We have a thing called the ThoughtWorks radar that we look at different patterns and so forth, and we came out and we said this one recently, this anti-pattern of CI theater. It's like, yeah, we're doing CI. I have 19 unit tests on, and so, wait, okay, that might be low. So, we did a survey, and this is the one that scared me the most. I work on a product called GoCD. It's a continuous delivery server, continuous integration server. It's open source, feel free to download it. That doesn't mean you're doing CI. Okay, but only 10% of the people differentiated having a tool that ran some automated things versus actually doing continuous integration. We have a test for CI. This is another one that some people don't like very much. And I don't know if I'm as adamant about it as Jez and Martin who wrote it. But to us, continuous integration, every developer committing to the shared mainline at least every day. Now, with distributed version control systems, yes, the first thing you do is get checkout-b, you create a branch. But to us, if you're doing CI, that branch gets a pull request or it gets merged back into trunk, main-like, master, call it your name, at least once a day. Every commit triggers the automated build and test. And the big one at the bottom, if build and test fails, it's repaired within 10 minutes. Okay, so we had a debate, discussion, whatever you want to call it, in one of the open spaces yesterday. People are like, well, I want to run all the tests in CI before I merge to master. And that's not wrong, but it's also not what we would do. To us, we count on the CI server to catch and turn it red. But because we're deploying so often or pushing so often, it's very easy to fix it when it goes wrong. And again, we have small product teams, so it's not 10,000 people or even 400 people pushing to the same master. It's a dozen. So this is why I say all these things are intertwined. It's easy to do this if you have the organizational structure that does this. It's not easy to do this in some others. So this is a very old chart of continuous delivery pipeline, what it looks like. If you look up Wikipedia CD, you see this. The idea is that, faster on the left, slower on the right. Old news to everybody here. I do want to make sure that people understand there's a difference between continuous delivery and continuous deployment. The difference is on continuous delivery is your software can be deployed at any time. So somebody can go up and click a button and deploy to production right now. Not, oh, I need to do it in an hour, right now. Continuous deployment is if all your tests pass, it just ends up in production. That's the only difference. I think there's the level of tests, everything else is exactly the same. The choice is business and business model. So if you're a SaaS product, by all means, do continuous deployment. Test things out at the smallest possible thing. If you work for Adobe and you give me a new release of Photoshop every day, I'm going to be very angry with you. Okay, so it depends on your business. So we go back to our teams. We said we had product, security, and compliance. What's their role in continuous delivery? I want to give the developers a path to production. I think there's a talk later talking about, should developers have access. I want the development team, I said developers, I shouldn't have said that. I want the development team to be able to write software, put it through a pipeline, run all the tests, or doing all the tests, and have that end up in production. But this rightfully scares the heck out of people. It would not be hard for me to go sign up for an Azure account, do a really bad application, put ThoughtWorks logo on it and deploy it, and get us in a lot of trouble. So rightfully, this scares people. So we still need to do some things to make it safe. So things that are bad, things we want to avoid. Deploying insecure software is pretty bad, non-performant software. Your performance doesn't have to go down a lot before you give up. Okay, I'm on a not very good roaming plan from my US cell phone, and for Cahoots this morning, I stood next to somebody else, put my phone in my pocket. I wasn't going to wait for it to load. Non-compliant software, GDPR, yeah. Ineffective software. Did our feature actually make our business get better? Whatever that measure is for you. We need to measure those things. I'm going to skip by this one for time, but I do go to this one. Your CD pipeline is there to protect you. It's there as a safety net. Every time you commit a change, that could be a chef recipe, it could be source code, it could be a test, it could be whatever. Every time you submit a change, that's a release candidate. It's the continuous delivery pipeline's job to prove it's not good enough. Okay? You can't prove something's good. I can make it green all the time, just not putting any tests in it, CI theater. Okay, but you absolutely can prove something's bad. You can't prove something's secure, but you can prove it's insecure. Okay, that's the CI's job, is to make it so you feel safe clicking the button and walking away. So if we go back to the pipeline, what I would like to see a whole lot more of is, I don't mean in a pipeline that I have jobs and this one runs Chrome and this one runs Firefox in parallel. I mean that every time I build my new Docker container and I've run unit tests, I've got to some level of confidence, that my server then picks it up and runs a whole bunch of other tests. So I can have people that are, inspect or server spec experts that are writing those tests. I set that as a dependency in my pipeline. So as a development team, when I create the new Docker container, as soon as that passes, my pipeline starts doing the functional tests. Their pipeline does the Docker pull and starts running all the compliance tests on it, or all the security tests, or all the performance tests. I don't do these in line because I don't want to slow it down. I don't want to say, I'm not going to run the functional tests until the compliance tests are done. Or, I'm going to deploy staging before I do security tests, or what have you. I want to give the development team the access to production that they need to be reactive to their business, but I am going to put a hard dependency at the end there on the right. If everything doesn't pass, then it never gets to production. Okay, in this way, I'm running things like compliance and security, and add your thing there, performance, whatever it is. I'm adding those to every single build. With public cloud, it's not free, and I'm not, cloud isn't, sorry folks back there, cloud isn't the answer to all of the world's woes, but it is cheap enough that I can do things in parallel pretty easily. And any modern CI/CD server can do this too, so this is not like product specific at all. As you may have noticed, there's no silver bullet. Okay, I don't think you can just automate your deployments and get to where you probably want to get. When you look at the state of DevOps reports and you look at the companies that have made financial gains based on how they're doing these things and so forth, they changed everything. They did org structure and what have you. There's ways to do this to start. There's a bunch of good books on it. Speaking of which, homework. These are solved problems, though. So participate in the local meetups. Go to more Devopsdays events. Go to Velocity. Go to get different types of events. Hear from different people. Read different things, etc. These are 4 relatively at random books. There's bunches out there, but these 4 I've actually read and know that they don't suck. Yeah, so they're pretty good. So summary here, and I know this was really fast, but I'll be around to answer questions later, is I do think definitions of words are important. Andrew Clay Schaefer and Patrick Dubois, who kind of came up with the term DevOps, actively refuse to define it. They're like, as soon as I define it, someone's going to sell a certification. Well, they did anyway, okay? But it's not the same for your organization as the organization next to you. If the person sitting next to you right now isn't from the same company, your definition might be different. That's okay, but please have yours that your team agrees on. You might have to do some organizational change. I know nobody likes reorgs and so forth, but you might have to do the architecture the way you want to, so modern architectures. If you have an organization that has 100-person dev teams, it's going to be very hard to do the fast, fix your build within 10 minutes, those kinds of things. And the point of CD is a safety net. It's not there to make things faster. In fact, if you're doing all of the things, if you're doing feature branches and branch by abstraction, or sorry, not feature branches, feature toggles and branch by abstraction, and running all the tests, and running performance tests every time, you're running compliance tests every time, it's actually slower. Okay, DevOps does not make you faster. DevOps makes you better. Thank you.